Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, hello everybody, and welcome. Thanks for coming to this talk. This work that Daniel Perlman is going to present is originated out of some discussions that Sumit Gulwani and I had with Daniel's advisor, Dan Grossman, from the University of Washington, really about programmer productivity and ways to improve that. Come on in. Daniel will present Intellisense for the 21st century, type-directed completion of partial expressions. So, Daniel, take it away.
So today I'm going to talk about a technology that all of you are familiar with and probably use on a day-to-day basis, and how I think that it can be improved. As Tom said, I'm Daniel Perlman. This is joint work with Sumit Gulwani and Thomas Ball here at MSR, and Dan Grossman over at UW. So I'm going to start walking through what I think is a rather typical API discovery task. I'm going to be talking about a programmer working on the Paint.net image editor who has an image and a size and wants to shrink this image to that size. But the programmer is new to the API and doesn't know what method does this. The programmer is most likely going to start searching through the API by just bringing up an IntelliSense window. I'm going to type in image dot and just expect this to be a method on image, just look for things that have to do with shrinking. It's going to sort of skim through this list, scroll down, page down, and find that there's nothing to do with shrinking in this list. Now, there are a few things in this list that could possibly apply. There's a size and width, but you can't tell by looking at this, but those are read-only properties, so they aren't helpful in modifying the image. So now the programmer, having failed to find what they want here, is going to probably just start looking through the other lists using IntelliSense, saying, oh, maybe it was under size, which it turns out doesn't make any sense because this is actually part of the .NET core libraries, not part of Paint.net. And after that, probably is going to try to start enumerating all of the static methods and hoping to find what they want somewhere in here. Just scrolling down, trying to figure out if any of these classes or namespaces sound like they have to do what they want to do. Say, oh, maybe it was static on document. Not there either. At this point, the programmer is probably getting a bit frustrated, wondering who designed this API so poorly, and is going to run off to the web and to do a web search to try and see if someone on the internet can tell them how to do this. So they run a web search. None of these results have much to do with what they're trying to program. Now, so at this point, maybe they should try using a better search engine and still get no results. We'll try a few different search queries with different keywords and find nothing. As it turns out, they're not going to find anything because Paint.net is a freeware project developed by a very small core development team. So in order to find any information about it on the internet, you'd have to send someone an email or find them in an IRC room or something. So the programmer could do that or continue searching through the list of methods and eventually going through all the namespaces. They'd find, oh, there's a resize action. Nope, that's not it either. It can resize layers, but not documents. Going back, you eventually come upon canvas size action, resize document. So this whole this was a lot of work. I mean, obviously, it didn't take too much time to scroll through all these options because this was a moderately small API and it came up moderately early alphabetically, so it wasn't too much trouble. But the programmer here says, I have a document in size. I want to shrink the document. I know there's a method to do this somewhere. And wants to be able to tell the IDE this and get a result and just continue programming without having to spend this time on searching for the method manually. Current IntelliSense is not designed for this task. It allows you to type things in left to right and gives you a complete alphabetic list of the next token based on what the receiver is, and doesn't filter based on any particular information the programmer may have. It's reasonable since IntelliSense is designed to help you type quickly, not find methods that you want to call for the most part. It just happens to get used for that. So my proposal is that instead the programmer should be able to tell the IDE, I want to call image.shrink new size. The IDE says, there's no method shrink, but here's these other methods that take an image new size and might be what you want. So this is saying, this is a list of methods that it found that take the type document and size, and also these other types. Because in this case, the programmer probably didn't know a priori that they needed to hit this anchor edge and a background color when they're resizing the document. They weren't thinking of that. And it's also going to come up with other options that turn out to have nothing to do with what the programmer was thinking. So the problem here is that numerous unfamiliar APIs are difficult to navigate, and as we have more and larger libraries, it's more common that programmers will have to deal with APIs that they are not familiar with and be able to find what they want to do within them. And also, this programmer wanted to shrink their document, but the method they wanted to call was resize document. So knowing the right names for APIs is part of the difficulty. So simply searching by name, which is what the current tools are helpful for, isn't as useful. So we have this programmer thought process. But what we want the IDE to be able to do is to support adding arguments to the query, reordering the arguments, renaming the method, or even appending path expressions to arguments. That is, perhaps the programmer provided one argument, one value, but the method actually only takes a specific property of that value. We want to be able to offer these as options to the programmer. So there has been some prior work in doing type-based searches of code. The first one is Jungoids, which is a system for Java that's based on the concept of doing conversions from one type to another. The example is in the Eclipse IDE. They have an I file, which is just a normal file reference to a Java file, and they want to get a syntax tree, which is of the parse Java file, which is represented as an AST node. But to do this conversion, they have this middle step of creating an I compilation unit that the programmer can't easily search for. So their tool will take the input type and the output type and produce this code by searching through the API. So this is generating an entire expression at once. The actual tool they present uses the locals as the source types and the context as the return type, as in you'd type AST node AST equals and then call their tool. This is somewhat different from what I'm proposing because they're only talking about using one input value and not multiple. And I'm suggesting using multiple input values to create more complicated expressions. Secondly, there's isynth for Scala, which also pulls in the locals and all the APIs around and tries to piece them together into different expressions. And this will create more complicated expressions, and they attempt to pare down the list a bit by not returning results that violate contracts. This, unfortunately, doesn't seem to scale that well. They only present using it in APIs that have a few hundred methods. Lastly, there's the Google tool for Haskell, which allows you to just add a command line, type in a Haskell type, and it will return all of the functions from the Haskell library that have that type. This does not make any particular attempt to rank the results, and it also is searching by more or less exact type. It doesn't offer results that have other arguments that the user didn't think of. So in general, what I'm suggesting that's different from these tools is I want to be able to present methods that have arguments the user didn't think of providing. I want to rank these methods in a way that's useful to the user. And I want the user to specify which arguments that they expect, which will help in filtering out which results are meaningful. So my proposal is that I want to make searches that look like code, but are incomplete, partial expressions. So I have this example where the user knows that they're in a key-pressed event handler. There's some collection of keys that are down, and they want to add information from the key event to that. To do this, the tool should be able to tell the user, oh, the right type you need is the key event key data, and also this collection needs to be told the key time info of when the key was pressed. Or going back to my running example, if the user wants to shrink an image, the program should be able to tell the user, you need to call resize document, put in the image and new size here, and then also need to know these anchor edge and background color arguments. Key here is that we are using types as the primary search key. That is, this search means find me a method that takes a document and a size. So to write out these partial expressions, I'm writing them like this with the question mark, meaning we don't know what the method is, and these curly braces to remind us that this is a subset of the possible arguments, and they might not even be in the right order. So just in general, the question marks is a hole where something needs to be filled in. And I'd like to emphasize that the search style complements Intellisense. In particular, I expect this to be useful for API discovery and not particularly useful for typing fast. So now I'm going to summarize my general approach of how this is going to be implemented. So the workflow of this is that the user is typing in some text into the IDE, and this is somehow going to be parsed into a query. I have not written a parser. I do not have a particular UI in mind at the moment. So taking this method query and the static type context and a library interface in order to know which methods could be called, this will be combined into determining a result set of every possible method that could be called with those arguments. Then, because this is going to tend to be a lot of methods, in order to make this useful, the results will be ranked using a heuristic ranking algorithm to present the method calls that the user most likely meant towards the top. To formalize the queries, I have this query language where the first two lines define a simple programming language where I have variable references, field lookups, and method calls. I'd like to highlight that I am writing instance methods with the receiver as the first argument, so instance and static methods look the same in this language, just to simplify things. And then I have these versions with the tilde on top to indicate that they're partial expressions that need something to be filled in, where I can either add a dot question mark at the end of an expression or use a question mark and the curly braces as my method call saying we don't know what method we're calling. So example here is that you could imagine the Visual Studio UI taking image.shrinkNewSize, recognizing that there is no method shrink, and converting into a query that looks like that. Now, to generate the results, we take the query. We have two arguments. So we just simply enumerate every method in the library that takes a document and a size, or a size and a document. Now, you'll notice this would not actually find resize document because resize document had 2 other arguments. So we need to also consider there being additional arguments past the ones that the user specified. And also, as I had said before, we want to be able to support the user not specifying the property of an argument. In this example, we have a string builder and an exception, and we have some debug log or something, and we want to append the exception to the string builder, and we want the tool to be able to recommend, oh, you meant to append the stack trace of the exception. And we can write this formally from the query language using rewriting rules. The first one says that we can just add a question mark onto our partial method calls, saying, oh, there's another argument we didn't know about. And the bottom row is talking about what we can do with the dot question mark. Either just ignore it, or we could make a method call. We call this could be a static method call with 1 argument, or an instance method call with 0 arguments. Or we could append a field lookup. And for those 2, you'll notice I left the dot question mark on to say there could be more than 1. Now, this is going to end up with a lot of results, especially once I add on that rule saying that we can do this multiple times. In fact, a little work will show this actually gets you an infinite number of results, which would take an awful lot of time to read through. So you could simplify this just by declaring a hard cutoff of applying these rules 1, 2, 3 times, something like that. On the other hand, you would still end up with a lot of results, so we need some way to rank them. Here's an example of if you had a string and a string array, here's some results you might get. They vary between reasonable and what you probably meant to completely crazy and very unlikely to be what you meant. So some of these like comparing the lengths to each other, which, unless you're doing something very strange, is not what you meant. Or comparing their types, which always returns false, so it's almost certainly not what you meant. Concatenating them all together, or could use the string as the format specifier when converting the length of the array to a string. I actually didn't read the documentation, so I'm not even sure what that means. Or some more reasonable things. There's a few different string operations that make sense taking a string and an array of strings. You can join the array together, you could use the string as a format string, or you could split the string using the array as delimiters. In the last case, you would need to specify the extra details of how you want the split to work. So in order to order these, I'm going to discuss a few different heuristics for doing the sorting. As I was reading through these, I mentioned some semantic reasons why they don't make any sense. I can't expect my algorithm to understand the semantics of these methods. So instead, I'm going to rely on heuristics that seem to work well in practice. The first heuristic I'm going to discuss is type distance. Since the concept of my search is that I am searching for methods that match the types of the arguments I'm providing, I'm going to want to prefer methods that take the exact type I've provided. So if I provide a rectangle, methods that take a rectangle are probably more likely to have to do with what I'm doing than methods that take a shape, which in turn are much more likely to have what I'm doing than methods that take an object. So I'm going to write this metric of how far up the type DAG I have to go and use that to prefer methods that takes types lower down on this DAG. Next, I had this concept of path expressions starting from the arguments the user provided, which is certainly can be useful, as the example I had before where I wanted to stack trace an expression. But as you put more and more of them on, you tend to get less related to the original argument. So I'm going to want to prefer results to have fewer of them. In this example, .getType.toString has very little to do with the original array of strings. It's unlikely to be what the user meant. The last heuristic I'm going to discuss is looking at subtypes of strings. Strings get used for a lot of different uses. Paths, font family names, icon names, and it would be nice if when the user provides a font family name, we don't recommend file operations. So I have this example in the bottom where the user asks a query for something to do with a font family name, and we want to tell them recommend create font and methods like that. In order to do this, in order for this to be useful, we also need this to be automatic for any subtype of string. That is, we can't hard code what a path is, what a font family name is, what an icon name is into the program. We need to be able to discover those automatically in any other subtypes that we might not have thought of yet. In order to do this, I'm going to use an algorithm that's based on the Lackwit paper, which did a similar thing for ints in C. It's just a simple type inference algorithm where every method, return type, and parameter that involves a string gets a type variable assigned to it. We use basic data flow and unification-based type inference in order to determine a set of subtypes of strings. For example, there's these two methods, get temp file and get file name, and they both get used as the first argument to change extension. Therefore, our algorithm can know that they have the same type. The problems with this method tend to derive from accidentally merging subtypes that are not actually the same, which means that we might present file methods when presented with a palette name, but we still can avoid showing, say, font family or icon name related methods. So it's not so bad. Also, I'd like to note that this takes some time, but can be done in the background. So it doesn't need to be executed on every query. So I don't expect you to read this slide. This is just showing that we have some score that these metrics are combined into, and we compute this score for each result in the result set, and then sort the results, and that's the ranking mechanism. Now, I'm going to talk about the experiment that I've performed. I have not yet implemented a UI for this, so the experiment is completely quantitative results on existing code, simulating using this algorithm on existing code. So I did a binary analysis using the Phoenix compiler framework to read through several mature C# projects. For each call with at least 2 arguments, it took the call and produced a set of queries from it. For example, for this call to resize document, it would take each argument and make a query using each argument, and then make a set of queries using each pair of arguments, and a set of queries using each triplet of arguments, and would evaluate how well each of these queries did at guessing the call, which is, in this case, resize document. That the evaluation would be, we have some length result list, and we want to know what position number resize document shows up at. These are the projects that I use. They're all mature C# projects. It's a combination of both user-facing and library code, as well as a combination of closed source and open source projects. So here's the evaluation. On this graph, the rank along the bottom is what position number the correct result showed up in. That is the actual call we found in the code. And the rank, so rank 1 means that using one of those queries, that is knowing just the types of up to 3 of the arguments, the actual call in the code, the actual method call in the code showed up at the top of the list. Moving that happened about 35% of the time. Moving across here up to 20, for the correct result showed up in the top 20 about 80% of the time. In other words, we can predict a method call from its arguments up to a set of about 20 possible method calls about 80% of the time. I'm going to overlay on this graph a breakdown of separating instance calls only and static calls only. At the top, we can see that instance calls do slightly better, and it does somewhat notably worse on static calls. I'm not entirely sure why this is, but I suspect that it's because that searching through all of the static methods is simply a larger search space. You have a question?
This is an average over all of the different possible patterns you generated off the
this is
method call?
So I'm
Or for
taking
one
the
particular
best.
pattern?
I'm taking whichever one of those did the best, which is admittedly somewhat unfair.
Did you find that certain patterns always tended to be the best, or a small number of patterns were the best?
Well, in general, we're going to expect that the pattern with the most that takes the most arguments is going to be the best, but I'm going to get into that more specifically in a moment. So,
I mean, it's a great question, but if some method takes a foo and 2 ints, you want your query to involve the foo, not the 2 ints.
Yeah.
But
yes.
For this experiment, you tried all subsets, including one.
The concept of this is that most likely 1 or 2 arguments the user is going to think of when thinking of what method they want to call are going to be the ones that are going to be successful at finding the method. Unfortunately, I can't automatically figure out which arguments the user would think of. But on the next slide, I'm going to focus in on the results at just this 20 line, where, so first, this is just a graph showing the calls that how many calls I looked at of each number of arguments. Recall that I'm combining the receiver into the argument set. So this 3 here is the number of static method calls that took 3 arguments plus the number of instance method calls that took a receiver and 2 other arguments. So now here, this is looking at only queries that had 1 argument. So the type of one of the arguments was able to predict a 3-argument method call 54% of the time. So that's requiring only one of the 3 arguments. If I then add in queries that have a second argument, that is, 2 of the types of the arguments, I'm able to get up to getting the correct answer that is within the top 20, 86% of the time. Now, if I throw in the 3rd argument, so for our 3-argument calls, we're looking at the types of all of the arguments, I get practically no difference. So this is sort of supporting what I was saying before, that few of the arguments are generally enough to decide which call we want to make. And that I wasn't necessarily gaining all that much by throwing in all 3 arguments. Now, yes?
What does the inverse of this look like in the ways that no matter how many arguments you added, you never found the right method?
So I don't go above 3 arguments because when I added 4 arguments to the graph, it wasn't visible. And obviously, once I have all 3 arguments, that's the best I can do. So there's this space that didn't end up in the top 20 any of the time, which is the remaining 12%. I'm not sure what more I can say about that. Could you clarify your question?
If you looked at top 100, would the method have been in there?
Yes, although if I go back to this slide, you'll see that after 20, it was notably leveling off. So it's going to be in there eventually, since obviously if you look in the top 10,000, they're all going to be in there somewhere. But you're not getting significant gains going much further. And more or less why I cut off the graph here. Okay. So this doesn't necessarily tell you much about how useful the tool would be, since I started this talk saying that I'm going to make Intellisense better, but I haven't yet given any argument that this is actually better than Intellisense. Naturally, any comparison I make to Intellisense has to be an apples to oranges comparison because they take different inputs. In particular, especially for static methods, Intellisense has to be told what the receiver is. This is a significant bonus on static methods, but it's still a bonus on instance methods if I'm specifying multiple arguments in my method, and my algorithm has no information on which one is going to be the receiver. On the other hand, obviously, knowing multiple arguments to the method is useful in filtering out which method you want to call. So an Intellisense doesn't use that information. So I'm going to present the comparison of the simulation of typing in the receiver, hitting dot, and looking how many entries down in the Intellisense list you have to go, and taking the difference of that from how many lists how far down in the list my algorithm gives you have to go. Yeah?
Why didn't you give preferential treatment to the receiver? I mean, it seems like if the programmer is not sure about how to use the API, if they have a receiver, that's something that they already have in their program, right? So they already kind of have a handle on it. It seems like you should treat that special and not treat it so equally with all the other arguments.
So you're saying that I should allow the algorithm? Basically, it seemed to work pretty well when I didn't give preferential treatment to the receiver, so I didn't see any reason to change it. It might make sense to, in an actual implementation, to say, yes, whichever one the program wrote down as the receiver is probably the receiver. Try to put their methods first. Is there another question?
So the Intellisense list is alphabetical?
Yes.
Okay, so have you considered the possibility of just reorganizing it by frequency of use, which would make it, yeah.
No, I have not. There actually has been previous work that did that, but I haven't compared against that.
It's also very interesting for API discovery. Do you want the frequently used ones or the infrequently used ones?
I
know about equals.
I actually had someone tell me previously that I should try taking all the methods that are frequently used and not presenting them, because obviously the programmer already knows them. I'm not sure which is actually the right choice. So to give some intuition for how this is going to compare to, Sally?
Comment. I mean, in a way, Intellisense is there so that we have to type less, whereas this is different, right? You're actually trying to discover something.
Right. Yes.
And so it's actually solving a completely different problem.
Yes. So sort of the way I'm looking at this is Intellisense gets used for API discovery, but it wasn't really designed for it. So yes, we're solving a different problem. So to give some intuition on how this is going to compare to Intellisense, our algorithm is going to do notably better on instances where the arguments have interesting types. In particular here, I'm saying that there is a error type enum as the argument here. If you have an enum, there's probably going to be relatively few methods in your library that deal with that specific enum. So that's going to help our algorithm a lot, but give no benefit to Intellisense. The two are going to be about the same when you're dealing with, for instance, methods of system.object, because there just aren't that many things to do with an object, and neither algorithm is going to have many options, so the difference can't be that big. Algorithm is going to do significantly worse. First, going back to that, if the user does want to call dot equals but has two enums, then my algorithm is probably going to do poorly, or just has two of some richer type than object. It's probably going to do poorly because it's going to be preferring methods that take more precise types, and the user is actually calling a method that takes object. Also, of course, since we're in alphabetical order, Intellisense does significantly better finding methods whose names start with the letter A. So here's the comparison. The difference here, the minus 50 means that it showed up on my algorithm 50 spaces higher than on Intellisense. So that happens about 5% of the time. We go over to 20, we get 20 spaces higher about 20% of the time. And on the other side, Intellisense does 20 spaces higher about 15% of the time. And there's this big middle space where they really do about the same, plus or minus 10, not a huge difference. Yes?
Right now you're using ranking as a proxy for the cognitive load involved in looking at that list and figuring out which one's the right answer?
Yes, which is notably nonlinear, but yes.
An alphabetical one, if you can scan text faster when it's alphabetical. Yeah.
This is a reasonable argument.
Because in yours, it's almost random.
Yes.
Which means that the reader...
You're going to have to read through every single one.
It actually slow you down significantly, just to read them.
Yep.
Yes.
Okay.
If it's not, what you're looking for is not in that top K.
Yeah.
But you could also take the top K and organize by assembly, or by package. I mean, you're right. There'd be additional work to do, but you could take the top K for some K and.
I should note that my heuristic ranking algorithm actually tends to get clumps of ties, which end up being alphabetically ordered. So, but still, you're right. It's going to end up looking significantly more random, and therefore take more time to read through than an equal number of equal-sized lists in Intellisense. So, on top of this, we could imagine including in our query the return type we want. In which case, that would significantly reduce the options in our list. But once again, Intellisense doesn't support this. So this line jumps up about 10 percentage points. So now we can get about 30 spaces higher about 15, 20% of the time, or 20 spaces higher, more like 20, 25% of the time. And on the other hand, now we end up only 10 or 20 spaces worse than Intellisense, only around 5% of the time. Also notice here that there's another 5% jump when we're talking about static methods, once again, because my algorithm has to consider a larger search space there. Yes?
I guess related to the previous question, there is a model. You have to have some kind of user model of what they will recognize as the correct answer. So they might know the name, for example. They might recognize the name, or they might have no clue what the name is. So what's your model?
So this is just telling you what position is going down and up in the list. So basically, I'm asserting that the user does not know the name but will recognize it. Okay. This, once again, might not be a reasonable model. Yes?
So this alphabetical ordering, this bothers me. It seems like it's completely unnecessary that in a way the Intellisense list, right? Sure, it's alphabetical. Whenever I hit Intellisense, I start somewhere in the middle of this list based on the last time I used it or whatever. So in fact, you should have always said, oh, the distance is half the length of the list, right? For any Intellisense list. This whole alphabetical thing seems to just, I don't know, I just put some random noise into this thing. This doesn't seem relevant, right? Because if I have to search for my Intellisense list, I will basically on average have to search half the list, right?
Well,
you don't
but
know.
you don't know
I shouldn't even throw the whole list.
It goes back to the question: does the person know what alphabetically they're looking for? Or
no,
not?
but he's right. Manuel is right that you don't know the name, but you have to browse through the list, right? You have to read one by one. Right. So the assumption is that it will be half the list that you have to go through.
Average.
It doesn't matter. Yeah, on average you go.
In Intellisense, you're reading one word on every line. This one, you're reading quite a long expression, right?
No, Intellisense also gives you a tooltip, and you want to read the tooltip for a
tooltip.
Yeah, you need to read all the arguments because all the parameters, because the assumption here is you use the method, the parameters too, the types.
Intellisense is only going to show one overload in that case, right? If there are multiple overloads, it's only be one on the list, and that might be the thing you want.
This will also only show one of the overloads. Yes?
Is there an assumption that you're making that if the user, while the user doesn't know the method they're calling or the sequence of methods they want to call, they do know the types? Like if they don't, like why assume that they know anything semantically about what they're trying to do? Like what if they,
Well, if the programmer has no idea what they want to do, I can't help them.
like what if they wrote size, but
I think
actually
it's a fair
they have to say rectangle or something? And
So
they got something that's close.
if they wrote size but they meant rectangle, then well, for one thing, there's likely to be a conversion from size to rectangle. In which case, my algorithm can say, oh, maybe you wanted to convert to rectangle, and here's these methods that actually take rectangle that get ranked a bit lower. So that could be helpful. And I'm saying that the programmer is probably at some point in writing their code, they have some objects around that they want to work on for the next step. And so that's sort of the base assumption. Yes?
This is based on analyzing calls and things that are in their program, right? Other information there, or do you just analyze all the referenced assemblies?
I'm sorry, I'm not sure I understand the question.
When you pull in, you analyze all of these sort of methods that are hanging around to figure out which one is relevant.
Yeah, so I look at each call in the program individually. I look at that call and apply the heuristics are completely local.
So if they are starting out with a blank project, they have nothing.
If they're starting out with a blank project, that makes essentially no difference to this algorithm.
No, but what's the denominator? What are you searching through? You're searching through all the core libraries.
Okay. So yes, it's the libraries it's searching through is whatever libraries are being referenced by the project.
The user didn't know they needed to reference a library.
I just mean if we're in the scenario of a user discovering an API, they're going to be starting out theoretically with this new API with a blank project that has nothing but a void main method in it, and there are no calls in their program from which to figure out things that are useful. And
this isn't leading other calls in their program. But it does need to have an input of which libraries to search through, which is currently based off just whichever libraries are referenced by the binary I was analyzing.
So it can only analyze patterns that are used in the library itself of accomplishing tasks.
It is not looking at existing code to decide which library to use. It is only reading through libraries to find out what method signatures exist, and then it is ranking which method signatures.
You only need metadata.
Yeah. You only need metadata.
You only need metadata.
Well,
There's a query.
and a query.
That's what he's saying. I think he's just, you're saying, I think he's just misleading because to do his experiment, he was using existing code to start out with a method call.
But I think there's something else with the subtyping, and for
Yes,
that you
that
do
is
use
not
calls,
local.
and that's for
That is
for
not
this
local, but you could run it
subtypes
on-
of strings you do use.
Oh, that's
It's
true.
not local, but you could most likely get most of the necessary information by reading through the binary of the library without having any code written by the user.
So you have to analyze the implementation of the library.
In order to get that information, yes.
So I mean, you could
Although that could be done ahead of time.
if you need metadata for things, I mean, if you point at the Microsoft symbol server, you'll get a lot of libraries that exist, and maybe your search space is really, really large, but at least you'll then not miss a library you might need to add.
Yeah.
Right, so I guess
Well,
there
the
is-
natural UI is I didn't find anything in the reference libraries. Do you want me to continue?
Yeah.
No, but it's an interesting question how the thing would scale to really huge numbers of references.
Yes, I can't really comment on that because that would depend on the mechanism you had for reading that metadata. I suspect that it wouldn't have too much difficulty. It just needs to be able to know the type hierarchy and know what method signatures are available. Sorry, are there other questions?
Yeah, so one other question. So this seems to have a potential to really work well with strongly typed system. Like if you have a good type system, right?
Yes.
So what about, do you have any experience or results about libraries that only have primitive types like integer? Because there can be methods that always take integer, string, character, whatever, right? And if you don't give me specific types, then this is not going to be able to direct its search properly, right?
Yes, there's going to be less useful in directing those types. As I had been talking about doing the subtyping thing for strings, you could certainly imagine for trying to do that on other primitive types. But yeah, that's not really the problem this is directed at solving, and I don't necessarily have a good idea of how to address that in a similar manner.
How does this work in a world where people are using a lot of type inference, where the kind of receiver, not the receiver type, but if I have a variable that I'm assigning into, I don't really know what the type is until I get the method that then returns that thing. You know?
That's why I showed this graph first, because I expect in real world you don't know what type you want. So this graph is more realistic than this one. This one looks nice, but this probably represents the real world better, because you're usually going to be using the var or auto keyword or whatever and not know what type you actually want.
I think this brings me back to the other question I had about what are you trying to do? Are you trying to save typing, or are you trying to actually make the user discover stuff? Because again, that's comparing to Intellisense seems to be the wrong thing here. For example, most of the times when I'm stuck, it's because I don't know how to get a text writer or a text
will you
reader,
hear when he said it's an apples and oranges comparison?
Yeah. We're still comparing to Intellisense here, right?
I'm comparing to Intellisense because, as far as I know, Intellisense is reading through the Intellisense list is how programmers tend to find methods. So I'm not saying that it's necessarily very good for that, so it's not necessarily that difficult to beat. But
is that the next graph is actually relevant because often I know what I want, but I know how to get it, right? So I need a text writer, but I can't just move up a new text writer because it's abstract. There's like this complicated thing I have to go through to get a text writer, okay? So this would help me, right?
Yes.
Because I could say, here's a string and I need a text writer.
As long as you're willing to write text writer, tell us this. Right? If you prefer to write var.
I'm just making the argument that comparing yourself to Intellisense alone is not really showing what you can do.
Yes, as I talked about the jungloids before, which is addressing the specific problem is I have one type, I want to get this other type, there's some random path in the middle that's completely undiscoverable. So that I would think would have to be, is definitely something that belongs in the IDE and is definitely part of an implementation of this. So my last graph is running time. This is the cumulative time to execute one query. This is saying that 95% of the time I can I can get the ranked results of a method query in under 1 second. I'd like to note once again, this is not including the time to do the type inference algorithm, which can be run in the background ahead of time.
But what was the size of the background library you searched to get that 1 second?
I don't know exactly. It was loading several dependent libraries. The binary sizes probably totaled up to a couple megabytes. I don't know, but including the .NET Core library and a few other libraries.
When you say .NET Core library, what is that?
Whichever assemblies were referenced by the code that it was analyzing. So not all of them, but whichever ones were actually referenced. So system.core.dll and probably a couple other .dlls that were around. These usually loaded around a dozen external .dlls, but I don't have.
These were mature projects, so we can expect that that's something somewhat reasonable.
Yes. Unfortunately, that's not necessarily comparable to what's going to be referenced by what's going to be visible from the Visual Studio context. This is what was visible from the binary context, which is hopefully comparable, but not obviously comparable.
What should I take away from this graph? Is it the ranking that takes this time, or is it the, I assume you already have all this stuff cached, right? So you're just kind of validating your ranking.
Yeah, ranking each result takes time. Just running the heuristics on each one and looking up all the data in the data structures. And of course, this information isn't necessarily stored in the most efficient way. It has the whole heavy weight of Phoenix loaded in the background.
So we should take this as an upper bound.
Yes, I expect an actual implementation to be able to run faster.
Well, an upper bound of 1 second for each query?
Yes. which I sort of drew the line at 1 second because I feel like that's a reasonable time to expect a user to wait for the window dialog to pop up. And much longer than that, they're going to get annoyed with the UI being too slow.
It's faster than going out to Bing. I mean, if you're comparing somewhere between Intellisense and somewhere between searching online, it's still 1 second.
Waiting a second or two is.
I mean, certainly some people might argue that no, you got to get it down to a quarter second, which we probably could. But I mean, we're talking on the order of human interactive speeds. So you care about things somewhere between 1/10 of a second and 1.5 seconds. I mean, that's where you have to play.
And because the person is exploring this API and doesn't exactly know, they're already in this sort of thinking moment. It's not like they're in the process of typing really fast. They don't know what to do.
It's typing thing, right? I've stopped, I've written a query, and I'm thinking about this and looking for something.
Yes.
Sorry.
So have you looked at incorporating like chunky frameworks like WPF or Silverlight or something?
I have not looked at those, and I am not familiar with those APIs, so I'm not sure how that would relate to this.
I'm just thinking that a typical developer is probably working inside a framework like that, and so which is why IntelliSense is really useful because they're big and they're many different calls.
I expect that for a GUI framework, this should be useful because GUIs are definitely an area where you have relatively specific types.
No, but are you saying that he should prefer, if you're working within a framework, then those should get higher rankings?
Well, that's possible. I think the question I had was about scale. If you have something like that and you throw that into the mix, does it make it much slower?
It's just the noise. And you said that you kind of analyze based on what was available from the binary. And I think the C# compiler strips out unused binaries. But when someone has a project, they may really have references to WPF and Silverlight and Windows and a very large number of libraries.
So what my analysis is doing is if there's any reference to a library, it has to load the DLL for that library and read the metadata from that. So hopefully it's actually getting all of the methods in that library and not just the ones that were actually called from the project.
But I think there's a very solid point here, which is that Daniel's going to probably get to future work here shortly, right? Which is, if you put this in a development environment, you probably have a couple orders of magnitude more sort of methods
and
nearby, and noise and all this sort of stuff. And does the performance scale? Does the ranking still work? These are all the questions you want to answer.
The ranking algorithm should be, essentially linear in the number of methods you have to look at, because you have to look at each method, decide if you can assign the arguments to the method's arguments, and if you can, assign a ranking score. Of course, then you have log n factor of actually doing the sorting, but
you can create fancy indices. You can make this like search.
Yeah,
you can make it.
It's an indexing problem.
It's
right?
indexing.
It shouldn't be.
So you haven't gone there at all.
No, there's obviously ways to improve.
I mean, you could probably take all the DLLs in the known universe and make it pretty efficient on that.
Yeah.
Right. I mean, how many? I mean, you would have the problem of types. Of people typing, anyway, you could probably do it.
Think of web search engines. They are instantaneous. The only problem is to do the ranking, not to find the hits.
Yes.
So the problem Bing or Google have is they have to run things right, not to find it.
Yeah, I was mostly worried about Phoenix not eating up all of my memory and loading the DLL, so I wasn't going to add to my memory problems by creating a fancy index.
Use a reference assembly, I guess.
That's good.
So my future work here is to consider other types of partial expressions. I've just really been talking about partial expressions where I have a method call and its arguments, and perhaps some of the arguments have that dot question mark on it saying that it's not exact. And I want some path expression starting there. Next, like to determine what would be a good user interface for this. I had some ideas scattered throughout the talk, but I'm not sure they're exactly what makes sense. And then to actually develop a Visual Studio plugin for this. And once I have that, to perform a user study and find out how useful this actually is, so I can have some more concrete data of how good an API discovery tool this is. So, conclusion, type-based extensions to IntelliSense can likely be useful, and this partial expressions language is sort of the key of how to talk about it formally. And
thank you very much. Wow. Just a little under an hour. Any more questions?
I would recommend that you also include common type conversions as sort of pseudo dot question mark operators.
Yeah,
that would create too much noise for your results.
I mean, yes, my concept from the dot question mark is to generally just plug in the entire jungoid result there and do any sort of conversions from one type to another was the concept. So yes, if there's common type conversions that are not actually accessible directly as an instance method, then that would make sense to put in there. Jungoids actually works by reading through all of the existing code and trying to find type conversions that way. Yes?
So I think you're going to get the most bang for your buck by designing a number of different UI experiences around what the scenarios are that you think users are going to be using this for. One thing about the Intellisense scenario is that if you type and you hit dot, you're not going to wait 10 seconds for something to happen. You're going to think the computer crashed. Whereas if you have a search box on the web page, you're willing to wait a couple seconds because you know it's the web. So a particular UI can give the user hints about the expectations of how long it will take, which means you don't have to speed things up unless you have a UI that convinces the user it's supposed to be fast. So by exploring different UIs, you can totally know the user as to the real performance of your system.
Well, that's right.
Yeah, I think you're absolutely right. Another thing that's sort of totally orthogonal to that is the quantitative data so far looked at like every method in some file. But in practice, we need a better sense of which of those methods would actually be queried about, right, to make sure it's useful. And that's just, completely 90 degrees off from how you do the query.
Definitely a problem that my results is looking at all of the calls. I have no reason to believe that any particular segment of the calls are ones that the programmer would need to do an API search for. Sorry, yes?
So I think another feature bug or addition suggestion that might be is like the question that I was asking about if the library always has integers or primitive types. I think this can be complemented by text similarity searching, basically other heuristic approaches, right? I think there was a question about can we use context, for example, the variable name, because if somebody's putting a dot, there's something before that, right? So the name that they gave to it might be useful to filter out some of the results and stuff like that. So
I agree that could be useful. There's sort of the synonyms problem of the programmer is going to use one name, the API developer might use a different name. There has been some prior work in trying to create dictionary thesauruses of synonyms, and I was basically ignoring this because I can't do anything about that automatically. But it's definitely worth considering for an actual tool.
Just for clarity, I consider kind of playing around with the title a bit. You've stated that your goal is not necessarily the type-fast scenario that Intellisense excels at right now.
Yes.
But the API sort of discovery scenario.
Yes.
And the titles like type-based Intellisense seems to sort of imply that this is a wholesale change to Intellisense, whereas this is really a supplemental feature that's focused on one scenario. It just to sort of message correctly what you're going after, I think it'd be better to say that as opposed to type-based Intellisense. This is more an alternative to Intellisense, or supplement to.
Yeah. Thank you.
That's kind of been repeated, but Intellisense is very, when we think of Intellisense, it's very clearly designed for two scenarios, that type fast completion and then that API discovery.
Yeah.
The idea of the query expression for this API discovery is is a really interesting concept, but don't tie yourself necessarily to Intellisense. Think about Object Browser and Navigate to and all the ways where you really want to do API discovery, and then maybe pull some of that into how it would be a natural flow in Intellisense. But don't necessarily be too tied to the UI, because the piece that's really interesting is the API discovery piece.
We can always use it as a find out.
I guess I was sort of thinking that this could be presented to the user as they type, in the same sense as Intellisense, which is sort of why I was thinking that. But I agree
context is important.
Yeah, I agree it's significantly different than Intellisense.
I think Intellisense does have an API discovery piece, so that's interesting to see how it plays into it.
Mm-hmm.
But then there's some things that you talk about that in terms of how long it's going to take for search or queries, people will pay for it in a different form.
Mm-hmm.
So that's the interesting piece that if we were thinking about how to design API
If it's already going to take
discovery.
me a couple of seconds, I will hit a keystroke and bring up another window to do that.
Yeah,
right?
yeah. And Tom's point that context matters here for what we're doing, you put it in the context menu.
Yeah.
Right.
Then we've got the cursor, we know,
And also the prior work of John Goyce and I had built upon the code completion GUI in Eclipse, and Emacs, but
Don't tie yourself. At this point, don't tie yourself to a specific kind of UI. Play around with a lot of them.
Yeah.
But for instance, in Visual Studio right now, our code snippets experience, you can type a question mark and you can hit tab, and that sort of brings up an inline sort of somewhat search list or completion list. It's not that you can't do it inline and you have to do a dialog box, you have to do something else. Just be careful about getting into that workflow of when the user hits dot or things. There are other alternatives that you can sort of cue people into this.
Okay. Thank you. So, are there other people with hands up?
Great. Thanks again.
Okay.